So in pre-calculus, we are talking about proving trig identities, and I think one of the trickier proofs from 7.1 was proofs that involve introducing something extra. The reason this is harder is that you actually have to think of something to introduce into the problem. You're not just manipulating the problem as it is. So for instance, if they ask us to verify that cosine u over 1 minus sine u is equal to the secant of u plus tangent of u. Let's start with the left-hand side. So we have cosine u over 1 minus sine u. Now, a trick that's used often is to use difference of squares. So if I see 1 minus sine u, that's a hint that I should multiply top and bottom by 1 plus sine u. Because when I FOIL or distribute the bottom, 1 minus sine u times 1 plus sine u is a difference of squares. 1 minus sine squared u. On top, I have cosine u times 1 plus sine u. Now, we know from the Pythagorean identity, cosine squared u plus sine squared u equals 1. If I take sine squared away from both sides, I get cosine squared u equals 1 minus sine squared u. This means that at this stage in the problem, on my left-hand side, I can substitute 1 minus sine squared u out, and so now my left-hand side looks like cosine u times 1 plus sine u over cosine squared u, using the substitution of the Pythagorean identity. I can then reduce the cosines, and I'm left with 1 plus sine u over cosine u. At this point, there's not much else I can do to this problem. I could go back again and introduce something extra, but it would really just take me back to the original problem on the left-hand side. Now I'm going to look at the right-hand side. On the right-hand side, if I look at secant u plus tangent u, and I change those into their sines and cosines, secant u is 1 over cosine u, and tangent u is sine u over cosine u. Notice that I have a common denominator already, so this must equal 1 plus sine u over cosine u. And so I've shown that my left-hand side is equal to my right-hand side, and I've verified the identity.